Let's take a look at some buffer sample problems here. So in this one, it just wants to know what the balanced equation is going to be when an acid or a base is being added to a buffer system. So first of all, let's recognize which chemicals are involved in the buffer in a net ionic way at any rate. So this guy here is clearly your acid because it starts with H and then they've given you the Ka. So your acid part of things is going to be HC3H5O2. And I know that some of these get really ugly looking and scary, but remember that an acid is really just HA, and it's just sometimes A is really complicated and ugly looking. I mean, we're used to seeing, HCl, HNO3, and those are fairly straightforward acid formulas, but really it could be anything. And when you start to get into the organic world with all sorts of carbons and hydrogens and oxygens in there, and nitrogens as well, things start to get a little scary looking, but don't be overwhelmed by it. It's just a scary looking formula, all right? Look at it through the right set of eyes, and in all reality, all of this, well, that's just a negative, right? Because that's H positive that is there. So don't freak out about some of the scary looking formulas that you're going to see in this unit and others, I suppose. And then they gave you sodium propionate here. So again, from a net ionic perspective, the sodium is going to go away, and since it's sodium positive 1 in an ionic sense, then it's going to be C3H5O2 negative 1, so that it can go with the NaOH, that's the positive one. So your conjugate base of this is going to be C3H5O2 negative 1, and that is the conjugate base. That's your A negative. So this is your acid part of things, and this is your base part of things. Now, what is it that we are adding to this system? We are adding potassium hydroxide. So again, from a net ionic sense, the potassium is going to go away, and we're just adding OH negative, which is the strongest base possible. All right, so that's your strong base. So what is this strong base going to attack? Is the strong base going to attack and react with the acid, or is the strong base going to react with the base? Well, we know from early on that bases like to attack acids. And so what's going to happen is that the OH negative is going to react with the acid part of things. So again, that's your acid part of the buffer. And then it is going to create water, and it is going to create the conjugate base, which is this guy over here, which is the whole point of this. And again, if we were to get into the mathematics of this, which we're not going to in this particular problem, we recognize that water is on the right-hand side, which means that this is going to go over 100% of the way. So we have taken the strong base and we have replaced it with the conjugate weak base over here, and that's how the buffer system works. So this here is the reaction that is going to occur when the strong base is reacted with this propionic acid, sodium propionate buffer